Question number 3. This question is of kinematics of motion in a straight line. This question is of kinematics of motion. A particle moves in a straight line starting from rest. The displacement s meter of the particle from a fixed point O on the line at time t second is given by s is equal to t power 5 over 2 minus 15 over 4 t power 3 over 2 plus 6. This is a displacement time relation. Find the value of s when the particle again at rest. Particle moves in a line starting from rest. Let particle start from point O on this side, because particles start from rest, so initial speed will be 0. The displacement s meter of the particle from a fixed point O on the line at time t second is given by, this is the displacement time relation. Find the value of displacement when the particle is again at rest. Suppose the particle is at rest at O, the particle is at rest. Next, suppose the particle is again at rest at this point. At this point again the speed is 0, because at rest we have to find this distance. This is s. So the relation between s and t is given, that is s is equal to t power 5 over 2 minus 15 over 4 t power 3 over 2 plus 6. First we will find at rest mean speed is 0. So to find the speed from this relation we will differentiate s with respect to t, that will be equal to v. So we can write that v is equal to ds over dt. Differentiating right side with respect to t, we get differentiation of the first term will be 5 over 2 t power 5 over 2 minus 1. Second term will be differentiated with respect to t. 15 over 4 remains the same because it is only a multiple. And so we are differentiating t power 3 over 2. This becomes 3 over 2 t power 3 over 2 minus 1. Next, the differentiation of 6 is 0 because it is a constant. So we simplify it, and this will be 5 over 2 t power 3 over 2 minus 45 over 8 t power 3 over 2 minus 1, that is 1 over 2. So because we have to find, because speed again at rest means speed is 0, so we will put this speed equal to 0. V is equal to 0 means this expression will be equal to 0. So 5 over 2 t power 3 over 2 minus 45 over 8 t power 1 over 2 is equal to 0. From here we will find the value of t first. We can write 5 over 2 t power 3 over 2 is equal to 45 over 8 t power 1 over 2. Now by cross multiplying we can mm, arrange these values. These by using cross multiplying process we can write t power 3 over 2 over t power 1 over 2 is equal to 45 over 8 multiplied by 2 over 5. By cross multiplying, we can write it as this. Now, t power we get from here t power 3 over 2 minus 1 over 2. Right side will be uh, this is cancel out. 2 fours are 8 and we get 45 over 20. Now, 3 over 2 minus 1 over 2 that is equal to 1. So, we get t is equal to 45 over 20 that is 2.25. This is 2.2 seconds. This means that speed again 0 at this point. So it will take 2.2 seconds to reach at this point where the speed is 0. Actually we have to find the value of s. So we have to find the value of s. We will put this value of t in the above relation. So at t is equal to 2.25, s will be s is equal to, it is given that s is equal to uh, t power 5 over 2 minus 15 over 4 t power 3 over 2 plus 6. Putting this value of t here, we get s is equal to 2.25 power 5 over 2 minus 15 over 4 t 2.25 power 3 over 2 plus 6. Now simplifying this term, first term, second and sixth, we get s is equal to, first term is 240 after calculating, we get 243 over 32, second term will be 405 over 32, third term is 6. Now we will simplify it, finally we get s is equal to 15 over 16 or we can write in decimal places 0.9375 or simply s is equal to the answer in three significant figures uh, 0.938. This is the answer. 0.938 meters. This is the answer. This is the value of x when the particle is again at rest. This s is 0.938 meter.